Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to see the assumptions in Annova. Already we have understood with the help of Annova what we can do. We have understood about factors and levels. Now there are some assumptions. If your problem statement satisfies these assumptions, you can definitely go ahead and use Annova. Okay. Now, usually when we discuss about z-test and t-test, we considered, right, some of the assumptions like your sample distribution will probably be normally distributed. And along with that, we saw in chi-square test, right, your distribution was right skewed. Similarly, in Annova, you have many more assumptions, many more basically means 3 to 4 assumptions, which you definitely need to know. And this can also come in the form of interview questions for all of you. Okay. Now coming with respect to the first assumption. The first assumption is something called as normality of sampling distribution. We'll make you understand what exactly this is. Normality of sample distribution of means. Whenever you think about or whenever you hear this term sampling distribution of mean, right? And when you think about normality, it's definitely central limit theorem should be coming in your mind. What does this basically mean? This basically means the distribution of sample mean is normally distributed. Okay, super important. And I hope you all know what exactly when I say normally distributed basically means. It should follow a Gaussian distribution. Coming to the second point. Now, absence of outliers. This is also super important topic, right? Absence of outliers. Now, the outlying score, even though you have outliers in a data set, it needs to be removed, right? So outlying score need to be removed from the data set. Okay, so even though you have an outlier, you have to remove the outliers from the data set, and it can be through multiple techniques like box plot, interquartile range. Many more things are there. In future engineering, we'll be discussing about that. Okay, now coming to the third topic, right? Third important assumption, that is nothing but homogeneity of variance. Okay. Now, homogeneity basically means homogeneous, right? So whenever we talk about population variance in different levels of each factor, in different levels of each independent variable or factor, independent variable, it should be same, right? Same, right? Are equal. I'm basically writing as equal. So in short, I can also give this notation as sigma 1 whole square equal to sigma 2 whole square equal to sigma 3 whole square, right? Let's say if I'm considering this in the form of 3 levels in an independent variable, then your population variance should be same. Okay, so again I'm repeating it, population variance and different levels of each independent variable are equal. Okay, we'll talk about more independent variable, but just a generic term independent basically means one variable will not impact the other variable, right? So this is basically called as independent variable. Okay, now coming to the fourth and the last assumption, which is also very important, that is samples, whatever samples are taken, they are independent and they are randomly selected. Okay, so I will write and random. So these are some 4 assumptions in Annova. Remember these assumptions because this can be asked in the interviews. I've heard about some of the students getting this question in the interview itself, and it is better that you basically know these assumptions. Again, I'm repeating it. The first one is normality of sampling distribution of mean. This basically means the distribution of sample mean is normally distributed. Second, absence of outliers. So this basically means outlying score needs to be removed from the data set. Third, homogeneity of variance. Population variance in different level of each independent variable are equal. Fourth, finally, which is the last one, that is samples are independent and random.